benefit of those who are not able to attend. Good morning, Luciana. I was asking if you had any lingering questions related to our discussion on Monday, which would have been descriptive statistics, probability, and contingency tables. Okay, thank you, ma'am. So I have started the recording for today. I am going to share my screen. And our outline for today is that I was going to see if you had questions. Apparently neither of you do. And so our topic for discussion today is going to be the normal distribution. If time permits, we will take a look at class participation activity number 7 together here in the Zoom room. If not, it will be due by Sunday, which is February the 5th. Also, let me remind you that your mindset learning activity number 3 is due by Friday, which is February 3rd. And then by Sunday, I know a lot of you have already turned in class participation 6. I have not had the opportunity to review those yet, but class participation 6 and class participation 7 will be due by Sunday, as well as the homework for contingency two-way tables, which was our discussion on Monday, and then the normal distribution homework. There is one question on the normal distribution homework that seems a little out of place, and it is a Z-score question, which we actually talked about in our class discussion on January the 25th. So you may want to go back to that lesson, to that video, and that discussion occurs at about the 1 hour and 45-minute mark. So you may want to go back and review that if you have trouble with that particular question. Also, as I was preparing for this morning's discussion, I realized that the PowerPoints, while they're good, and the videos that are in the module 2 for the normal distribution, they're good, but they're also a little outdated because they still have the instructions on how to use the calculator to perform the operations. You can do that if you have a TI 8384 calculator, but we're actually using Minitab to do that now. I don't know that necessarily one is better than the other, but I have provided an updated PowerPoint in the announcements. It's the one that I'm going to be using this morning during our discussion. I have a link to it. Also, I attached it as an attachment in case you wanted to be able to print one or more of the pages for that particular discussion. Again, remember, we have omitted the topic of binomial distributions. We are omitting, and I think I have that hidden where you guys cannot see it, but just in case you do, remember we are omitting that particular discussion because of the 8-week format that we're in. Okay, so do you have any questions before we dive in? Okay, thank you. All right, so we're going to use the PowerPoint again that I've posted in the announcements today, and we're going to be talking about the normal probability distribution. We talked briefly, and let me see if I can pull it back up, that particular PowerPoint, just a minute. At the end of the discussion on Monday, we were talking about the probability distributions, and I wanted to give you kind of an overview of probability distributions. And so we talked a little bit about that. I'm going to see if I can pull that back up. And we talked about how probability distributions really are a theoretical model of what should happen if everything worked or happens the way that it's intended. And there were two different types of probability distributions. You have discrete, which we are not going to focus on in this course, and you have continuous, which is the ones we're focusing on in this course. Again, if you take Stat 2401, which is Elementary Statistics 2, then we will talk about the binomial probability distribution in that particular course. We also talk about, I believe it is the exponential probability distribution. But I wanted to go back for just a minute, and I'm just going to Google probability distributions, kind of some real life examples, so that you can get an idea of how beneficial this information and how useful it can be. Because we use probability and probability distributions practically every day. Probably one of the most common examples is weather forecasting. Weather forecasters determine how likely it is that it's going to rain, how likely it is it's going to snow, and make a determination, and then they share that with the public so that we can be prepared. Obviously, most people connect probability or probability distributions with any kind of sports betting, where you are using the probability that a particular team is going to win a game. And so then based on that, you can get, a certain payout. You may not realize that probability or probability distributions are used in politics. You see this a lot, especially during elections. They try to collect data from the constituents, from the voters, to try to determine which candidate is going to win the election before the election actually even happens. If you are perhaps going to be studying business, probability can be used in sales forecasting to make a determination that you're going to sell a certain amount of product within a given day, a given week, a given month, if you're going into that field, so that you can maybe predict what your salary or your paycheck's going to be. They could also determine, how, if a particular item is going to sell or not. Insurance companies use probability distributions to determine how much individuals are going to spend on healthcare each year. They also can, if you think about life insurance, insurance companies think about what's the probability that you're going to live to be, 80 years old or 90 years old, or what's the probability that you may unfortunately contract some kind of life-threatening illness, and they base your premiums, the amount that you pay, on that particular amount. Even with car insurance, they look at your age and your previous driving record and that sort of thing to help set the rates for your car insurance. Any kind of staffing, the example here is a grocery store staffing. Again, it could be any kind of staffing, but you use that to determine how many workers you need on a given day. Think about staffing for nursing. What's, based on the probability that there's going to be a rush of patients in the ER. Do you have enough staff on hand? what's the probability it's going to be slow and you don't need all of those people on hand. So again, that gives you an idea so that you can plan or manage your workers properly. Obviously, natural disasters, they used to determine how likely that, a hurricane is going to happen. And then also to think about where the hurricane is going to make landfall, the chance that there's a tornado, what direction it's going to go, earthquake, that kind of thing. Again, so they can begin to think about what to do. Do they need to do an evacuation, or do they need to have a staging area, and that sort of thing. Traffic, thinking about how to drive somewhere based on the time of day, or the weather conditions. Should you, try to go down the interstate, or should you take some back roads, that kind of thing. Obviously, with investing, thinking about whether a stock is going to go up or go down over a period of time. Again, we base that on probabilities. So there are lots of uses, and I may not have touched on one that maybe is in your field, but hopefully you get a sense or a better understanding that probability and probability distributions are widely used in a variety of fields. And again, there are lots of different probability distributions. One of the most common, or one that is used the most, is the normal probability distribution. So that's the one we're going to focus on. Many of the others can be approximated or estimated using the normal distribution. So again, a probability distribution, it describes what will happen, probably will happen, or what should happen based on the chance, instead of what actually did happen. As I've just demonstrated, many decisions throughout business, insurance, other life situations are determined by assigning probabilities to a particular event and then evaluating those results. And I've went through some examples with you that I Googled, but also then there are a list of some examples here as well. So again, there are important uses of a probability distribution. Our focus is going to be on the normal distribution, and I haven't really drawn one yet, but a normal distribution has the following important characteristics. The normal distribution is kind of that nice, lovely, bell-shaped distribution that most people think about when you hear the phrase grading on the curve. So you typically, it's drawn, you have a horizontal number line, and then you have, this nice bell-shaped distribution. Okay, it's sometimes referred to as the bell curve. But to think about the characteristics of that distribution, one, it is continuous. The idea of being continuous means that there's no gaps or breaks, that I was able to put my pen down and draw the entire curve without lifting my pencil or my pen. The normal distribution is what we call symmetric, meaning that the left side is the mirror image of the right side. If you could imagine a line through the middle of the graph and you fold it in half, you wouldn't be able to tell the left side from the right side. Now that line, that dotted line, occurs at the mean. Okay, because remember, the mean is our measure of center. It is the most useful measure of center, but we also learned with a symmetric distribution, we talked about it earlier, that there's only one mode, and that technically the mean, the median, and the mode are all virtually the same value. But again, when you see this distribution labeled, we typically label that center point with the mean, because the mean is the best of those three measures because it uses all of the data values in its calculation and it's used in other statistical calculations. It is bell-shaped, as I mentioned. Again, that gives us the sense that most of the data is kind of in the center of the graph, and you have very few data values on either end. The shape of that distribution is determined by two different parameters, by two different measures. Those two measures are the population mean and the population standard deviation. And I can use any value that I could possibly think of for the mean. I can choose any value for the mean, and I can choose any value except 0 for the standard deviation. Standard deviation of 0 would mean there's no differences in the numbers, and that doesn't make sense. Plus, in the calculation of the normal distribution, it's in the denominator of a fraction, and you can't have 0 in the denominator of a fraction. So the shape of a normal distribution is controlled or determined by those two values. So you always need to know the mean and the standard deviation for the distribution, because it's different for every problem, or it's different for every normal distribution. So you have to be given that information. Now, because I can use any number for the population mean and any number except 0 for the standard deviation in any combination that I want, there are actually an infinite number of normal distributions. And I have some examples of different distributions on the next slide. And again, all three of these, whether you're looking at the green, the red, or the blue, all three of those are a normal distribution. They are symmetric, they are continuous, they're bell-shaped. You have, kind of a really skinny tall bell, or you have a bell that's kind of flat and fat. But again, you can have any value for the mean and any value except 0 for the standard deviation. And so there are an infinite number of possibilities. So you have to know the mean and the standard deviation anytime you're dealing with a normal distribution. Some additional characteristics of the normal probability distribution, and this one's a little bit harder to grasp, but it connects back to the rule that we talked about on Monday, that when you look at all of the probabilities, all the things that could happen with a particular event and total them up, it has to total to 1. Because remember, 1 or 100% in terms of probability means something's going to happen. Means it's going to happen regardless of what you try to do. There is a connection between probability and the area under a curve. That's actually the whole premise of calculus. And so we're not going to get really detailed. It's kind of one of those things where you're going to have to kind of trust Miss Ralston. But there is a connection between probability and the area under the curve. And so for a normal distribution, the area, if you look at the two diagrams here, that shaded yellow region is the area between the number line and the curve itself, and it has to total 1. And again, it's kind of one of those things that seems a little weird. I could prove it to you, but that requires calculus. So again, you're going to have to kind of trust Miss Ralston. We normally have the variable. The variable X is the quantity that we're measuring or that we're talking about. Again, you have to know the mean and the standard deviation. And sometimes when you're looking at research or looking at a report, you may see it written in this manner. This means that the variable X, I'll write it out for you, variable X approximates a normal distribution. The letter N is for normal, with a population mean, which is mu, and a population standard deviation, sigma. Instead of, writing it out in sentence form, in word form, that's kind of the shorthand notation so that you get all of that information very succinctly. Okay, so don't freak out if you see that notation. Again, it's just a shorthand that's telling you that your variable approximates a normal distribution with a mean of whatever and a population standard deviation of whatever. The first number in the set of parentheses is always the mean. The second number is always the population standard deviation. Again, I've mentioned the ways we use probability distributions, but there are lots of ways that we specifically use a normal probability distribution. When you think about determining the height of a population, most people in a population are of what we would call average height, and the number of taller people and shorter people tend to taper off. You don't have very many people who are extremely short, and you don't have very many people who are extremely tall. The technical stock market, we think about the rise and the fall of the stock market, but we can, if we assume that the distribution over a period of time, it models a normal distribution. The distribution of the economy, if you look at it over a period of time, this particular graph shows between 1970. Again, you have most people are what we call middle class. They're kind of in the middle. They have that average income. You don't necessarily have a lot that are extremely, extremely rich. And ideally, you don't have many that are extremely, extremely poor. Now, that may vary from country to country. Birth weight, when you think about the birth weights of babies, again, they tend to follow a normal distribution. So you can kind of predict the birth weights of newborns. Inventory forecasting. If you're working for a company and you need to, plan for what products you're going to need in the future, you can use a normal distribution. Again, notice on this particular one, I mean, guys, it's not necessarily going to always be exact, but you can still have that basic shape. Okay, it's not always going to be a perfect model, but it's close enough that we can use it when we're making predictions. Even blood pressures, the diastolic blood pressures, follow a normal distribution. Not that you care, but the volume of milk that is produced by cows follows a normal distribution. Most cows are going to kind of give you the same amount every day. You're going to have very few that produce a lot of milk or very little. You can look at the temperatures over time, and that helps us to think about climate change. So again, there are lots of uses for specifically a normal probability distribution. And the other thing about the normal probability distribution is I can use it to approximate other probability distributions like the binomial or the Poisson or the hypergeometric. Okay, so again, it is probably one of the most useful, or one that is used the most often within the world of statistics. And again, that's why we focus on it in this course. You guys are really at an advantage because we have the technology that will do the calculations for us. When Miss Ralston was coming through and learning about the normal distribution, I had to do it by hand. And that's the way a lot of statisticians and mathematicians did it prior to the advent of technology. And honestly, to do that, you have to use calculus. So there does exist calculus-based statistics courses. We do not teach one. This is not a calculus-based statistics course. So you would have mathematicians, researchers, whatever, doing these very lengthy, tedious calculations using this crazy looking formula here that you see in this left-hand column. Well, they kind of got tired of doing that. And so the mathematicians, researchers, statisticians said, well, let's create kind of a standard that we can compare everything to and create a table. And they had to create a standard because, remember, we can use any number for the standard deviation except 0, and any number for the mean in any combination. So we would have to have umpteen bazillion different tables. And so they created a standardized normal distribution. In a standardized normal distribution, they picked the easiest numbers they could to perform the calculations. And so they said the mean would be 0 because calculating with 0 is really easy. But the standard deviation they had to choose as 1, remember, because we couldn't choose 0. And then they created, through the use of the Z-score, remember our Z-score formula from the other day, they would take each value for X, they would do X minus the mean, and then divide it by the standard deviation. And even using a value of 0 and a value of 1, it could get really messy. But what mathematicians, researchers, statisticians did is they created a table. And I have a link to one just to show it to you. Whoops. Didn't take me there. Let me see if I can find one. Okay, there's lots of different Z-score tables. And again, this is how I learned it. Okay. You have the Z value, and the first column gives you the first part, and then you go across the top to get the second decimal. You have to know how to read the table. I mean, it just gets messy. And different authors use different formats. So it got, it's just messy. Again, that's the way I learned it. But for you guys, we have the technology. Again, we have a calculator. We can find free websites that will do it as well, but we're going to use Minitab, and it makes your life so much easier. It allows you to focus on the interpretation. What does that tell you? What does it mean? Not focusing so much on the actual hand calculations that I used to have to do. Okay, so do you have questions before we actually get into the problems? There are really two different types of problems that you'll see. There are two different ways the questions are worded, and you work them differently depending upon the phrase. The first set I think about is you deal with specifically a normal distribution. And the question may read something like, find the area under the curve, find the percentage, find the probability that. Okay, so you're going to see those phrases. Okay, so you're actually, in this particular scenario, looking for or determining the probability of a particular event. Remember, we're dealing with probability distributions. So you'll be looking at finding the probabilities. In the other scenario, which we'll get to in a little bit, you're looking more for, you're given the probability and you want to find the value that corresponds to that. You're kind of working your way backwards because you know the probability from the beginning. Okay, so let's take a look at some examples. I think I have, yes, I do. On the next slide, and this might be one of the slides that you want to print. Okay, and I was going to see what number slide it was for you. This might be, again, one of the few slides that you want to print because it has the steps that you need for Minitab, and this is slide 12. Okay, this is slide 12. Again, for exam 2, you'll be able to use your notes and things, and so you, again, may want to have this particular information close by when you're going through the homework problems, practice problems, and getting ready to take your test. So again, probability corresponds to the area under the curve. You need to read the scenario or the situation or the problem that you're given from beginning to end. You have to be told two things, and I've mentioned it multiple times this morning already. You have to be told the population mean and the population standard deviation. So you want to write those things down because those two pieces are going to be important. I would encourage you to draw a picture of the scenario. That helps you to decide what type test you're going to have, and we're going to talk about those as we go. But there are 4 possibilities. You can have what's called a right tail, a left tail, a between, or they call it an out. I call it an outside. Okay, and I'm going to go over and draw those scenarios for you in just a second. And then I give you the steps for Minitab. Now, it's important to remember, and we talked about this, remember we said that probability, all probabilities are between 0 and 1. That probability is never negative. And in this scenario, remember that probability corresponds to area. So area will always be a positive number. Your final answer should always be a positive number. It should also be a number less than or equal to 1. It should never be over 1. Never greater than 1. It always amazes me when students give an answer like 1.275. Guys, it cannot be 1.275 because probabilities are never greater than 1. Now, what's confusing to students is that sometimes if you're dealing with a Z-score, that Z-score can be negative. Okay, so let me go over and make a couple of notes for you because I want to remind you of a couple of things. Okay, I want to mention for just a minute about the Z-score. Remember, the Z-score is, or sometimes is referred to as the standard score. And again, its primary use in relationship to the normal distribution was really necessary before the advent of the technology. It really is not used that much anymore. But the formula that we talked about before is your data value that you're interested in, which is X, minus the mean, which is mu, and then we divide by the standard deviation, which is sigma. And we looked at how to use that the other day to make comparisons between different sized groups. Again, that's on the video from January the 25th at about the 1 hour and 45-minute mark. And you may want to go back and review that. But that standardized score, remember what it does is it tells us the number of standard deviations that a value is below or above the mean. The Z-score allows us to convert everything to a common scale, and then we can think about how far away that particular data value is from the mean. Now, the way that we know whether we're above or below, if we're below, we get a negative value for Z because I am less or below the mean. And if it is positive, I am above the mean. Okay, and I don't know for sure that I clearly stated that the other day. There is, and we're not going to spend a lot of time on it, but I want to mention it to you. Let me see if I can get me another piece of paper here. Okay, there is a rule that is sometimes used. Again, it's used, one of the applications where you could definitely relate would be the idea of grading on the curve. And this particular rule is one of the ways that we can verify that we have a normal distribution. It's sometimes used to verify a normal distribution. Now, and all of the problems that you're going to see in this course is going to tell you that the distribution is normally distributed. Okay? But in the real world, if you were doing your own research and you collected your own data, you may need to confirm or verify that you have a normal distribution before you use the normal probability distribution to solve problems. If you happen to have a data set that is maybe skewed to the left or skewed to the right, then we have to do something else. So the empirical rule is a way that we verify the normal distribution. And I'm just going to give you the rules because One, I think there's a couple of questions on the practice problems related to this, but I do know that there are not any questions. I took a peek a while ago. I don't believe there's any on your homeworks, but the empirical rule says that 68% of all the data values fall within one standard deviation of the mean. It also says that 95% of all the data values fall within 2 standard deviations of the mean. And finally, it really says 99.7% or almost 100% of all the data values fall within 3 standard deviations of the mean. I'm going to sketch you a picture here in just a second. Okay. Again, the empirical rule, I mention it primarily because I know there's questions related to it on the practice problems. I did not see any on your homework, and I don't believe there's any on your test. But again, it's the idea, think about the idea of grading on the curve, but it's used primarily to help us verify a normal distribution. So visually, what happens here is we typically have a horizontal number line, and you have your bell-shaped curve. And again, we have our mean in the middle. And what the empirical rule says is if I go 1 standard deviation below the mean, so we're going to subtract the standard deviation, and 1 standard deviation above the mean, between those two values, I would have 68% of my data. So this would be like having, you're going to have lots and lots of C's primarily, if you're thinking about grading on the curve, you know, a reasonable number of B's and a reasonable number of C's, D's, excuse me. If we go from the mean, if we go 2 standard deviations below, so we subtract the standard deviation twice, or we add the standard deviation twice, that between those two numbers, we're going to have 95% of the data. And if I go 3 standard deviations below the mean and 3 standard deviations above the mean, I should have virtually all of my data. If I have anything, you know, more than 3 standard deviations away from the mean, then we would probably consider that something very unusual, that it's an odd value. We might even possibly say that it's an outlier. Okay, so that just gives us a visual to help us verify, if we needed to, that we have a normal distribution. But again, for you guys, you're going to be told in the problem, in the scenario, that it's a normal distribution. You're not going to have to do that verification. Now, again, later, if you take Stat 2401, Elementary Statistics 2, then we do actually talk about verifying whether or not you have a normal distribution. Now, let me mention the 4 scenarios that you could have with a normal distribution. Okay, so when you're working with normal distributions, okay, which is what we're going to be focusing on, okay, you have to be told that your distribution is normally distributed. You should be told somewhere in the scenario that your distribution is normally distributed. You have to be told the population mean. That's the Greek letter mu. You have to be told the population standard deviation, which is sigma. If you don't know those 3 things, you cannot work the problem. You have to know that it's normally distributed. You have to know the population mean, and you have to know the population standard deviation. If you don't know those 3 things, you can't work the problem. Now, again, the first set of problems that we're going to focus on, you need a 4th piece of information. Okay, so I tend to call these type 1. It's not really what they're called, but I tend to call them type 1 just to try to help you make a distinction between the 2. And again, the question is going to say something like, find the probability that, or it may say find the percentage that. And so you're going to be given another condition, or be given a condition. In that condition, okay, so you're going to be given a condition, probability that, and you get a condition. In that condition, you're going to be given the data value of interest. You're going to be given a data value that you're interested in, and it's going to be, we call it X. And then it could either be greater than, less than, between, or outside. And so let's think about what that means for just a minute. Okay, so you could have values that are greater than X. Okay, greater than X. If I think about what that would look like visually, okay, you have a horizontal number line, you have your bell-shaped curve, your mean is the value in the middle, and then you're going to be given some value of X. And it doesn't matter where the X value is. I'm going to say that my X value is here. And you want to be greater than that. Well, greater than that would be any value that is to the right of the X value. This is called, because your region that you're looking for, we're really looking for, ultimately, what we're going to find is the area under this curve out here on this end. Okay, and so that region that we're looking for, that area that we're looking for, is on the right hand side at the end of the curve. This is called a right tail. Okay, so whenever you have the greater than, that is a right, we call it a right tail. And it's important to understand that because you're going to have to make that choice when you go into Minitab. You have to know whether it's greater than, less than, between, or outside. The second option you could have is it could be less than X. If it's less than X, again, you would have your normal distribution, single number line, bell-shaped curve. The mean is always in the middle. And again, they give you a value for X. And the value for X could be anywhere. But we want to be less than. Less than values are to the left of your X. Less is always to the left. And so the area or the region that you're trying to find for a less than is, again, this region to the left of your X. So it's on the left side. So we call this a left tail. The third option is they could give you a between. With a between, they give you two X values. They're going to say it's between the first X value and a second X value. So like we want to say it's between 1 and 5 or 2 and 7. It's between. So visually, again, you would have your horizontal number line, your bell-shaped curve, the mean in the middle, and then you have your 2 points of interest. You got 2 points now. And again, they could be anywhere, but usually X1 is going to be the smaller value. X2 is going to be the higher value. And you want to be between those two. So it's kind of like a sandwich. You got 2 slices of bread, and then you got what's in between. Okay, so again, what you're looking for ultimately is this area under the curve between those 2 lines. And I believe I'll have to double check, but we call this a between. I believe that's the term that Minitab uses, but I'll double check for you when we get to that point here in just a minute. Well, I got to get another piece of paper. I'm just going to open up a new sheet. I forgot to. Okay, so the fourth one is it could be less than X1, or, and sometimes you'll see the word and, greater than X2. So you've got 2 conditions, okay, that are connected by either the word or by the word and. Okay, so visually here you would have get it drawn here. Again, you have your horizontal number line, your bell-shaped curve. Your mean is going to be in the middle. You have your 2 points of interest. You have x1, which again is usually the smaller of the two, and it's less than. Less than, remember, is to the left. Or you have x2, and it's greater than, and greater than is to the right. So you actually have two shaded regions. Okay, you have two shaded regions, and they're on the ends or in the tails. The term that I tend to use here is the word outside. I forget what Minitab uses, but I'll try to go back and look it up for you. Okay, you're outside because you're on the ends. Okay, you're trying to find what's happening on the ends in each tail. This is actually, and I'll point this out because this is the one that sometimes students get tripped up on. This one is a special case. There's a special way that you have to calculate this particular problem. Okay, it requires a little bit more work than some of the others. Okay, again, the instructions for Minitab are on slide 12. I would encourage you, if nothing else, that you print slide 12 so that you have those instructions for Minitab. All right, I have 10:34. Let's take a break until 10:40. You can, get a drink of water, go to the bathroom, get a snack, whatever you need. And when we come back, we're going to dive in to these examples. I have 10:40, so we'll get started back. And we're going to take a look at the examples. While you were on break, I did go out and look the terms used in Minitab. They do use the term right tail, the term left tail. For the between, they use the word middle. Minitab does not have one specifically for the outside. It does have a fourth category, but it assumes that you have the same amount in each tail, and we do not necessarily know that when we're working the problem, so we don't typically use that option. Okay, so let's look at these problems. So example number 1 on the PowerPoint says, according to the American College Test, ACT, results from the 2022 ACT testing found that students had a mean score of 21.524 with a standard deviation of 2.419. Assuming the scores are normally distributed, find the probability that a randomly selected student has a reading score, ACT score, greater than 26. Okay, I want you to notice a couple of things. Remember, I told you there were 3 things you had to know. 1, you have to know the distribution is normally distributed. They very clearly tell you that. 2, you have to know the mean. They've told you the mean is 21.524. And 3rd, you have to know the standard deviation. Okay, so we have the 3 pieces of information that we need in order to work the problem. Then the problem says, find the probability that, and it gives us our condition. Our condition says greater than 26. Now, I could work the problem without drawing the picture, but the picture helps me to visualize what I'm looking for. So I'm going to draw a picture. I have my horizontal number line. I know that it's normal, so I have my bell-shaped curve. My mean is the measure of center and is always in the middle. And I know that that value is 21.524. Then I need to include my point of interest. Okay, my value of interest is 26. Guys, use a little bit of common sense. Okay, the horizontal number line, the mean is 21.524. 26 has to be somewhere on this right-hand side. There's my value of interest. And I want to be greater than, and values that are greater than are to the right. So visually, I can see that this problem is a right tail test. Or right tail, it's not necessarily a test, it's just right tail. So then I'm ready to go out to Minitab. I know what my mean is, I know the standard deviation, I know it's normal. So then I'm going to Minitab to do the calculations. Again, the keystrokes are on slide 12 of the PowerPoint. We go graph, probability distribution plot. I want to view the probability. I have a normal distribution. My mean is 21.524. That was given in the problem. My standard deviation is 2.419. That was given in the problem. I then click options. I have a specified X value. I have a specified X value. It is a right tail because it is greater than, so I'm selecting right tail. And then I enter the value, and the value we had was 26. I'm going to make you a note here. In the command, we use a specified X value. Whenever you see that phrase, find the probability, you're going to use a specified X value option in Minitab, and my value was 26. And I click OK. And I click OK again. And in the top half, Minitab actually draws the curve that I roughly sketched. Okay. And I'm going to copy it so we can talk about it. Let me see if it'll let me paste it here. Okay, so here's my graph from Minitab. It tells me that it's normal. The mean was 21.524, standard deviation 2.419. I can make sure I didn't enter it incorrectly. It shows the graph in this red shaded region. My answer is this value right here, 0.03213. Okay, so the probability that a randomly selected student has a reading ACT score greater than 26 is approximately 0.03213. Now that's a decimal. This is a decimal. If you need it as a percentage, remember you multiply by 100. So this would be about 3.2%. So we know that there is a 3.2% chance that a randomly selected student has a reading ACT score greater than 26. So if I'm thinking about it, and thinking about what that means, there's only a 3.2% chance that they're going to score greater than 26, which would be somewhat unusual. I wouldn't necessarily expect a student to score 26 because 3%, that's kind of close to zero. So it'd be very unlikely or unusual. Next question. It's the same scenario, guys. It's the same scenario that we just talked about. Okay. We have normally distributed with a mean of 21.524, standard deviation. Whoops, didn't change my color, sorry. A standard deviation of 2.419. And this says, find the probability that a randomly selected student has a reading ACT score less than 21.7, which was Georgia's mean ACT score. Okay, so again, if we think about this from a visual perspective, I'm going to draw it over here. We have our horizontal number line. We have our bell-shaped curve. The mean is in the middle, which is 21.524. My point of interest is 21.7 because my question says less than 21.7. Now again, guys, think about where that would be on this number line. 21.7 is going to be just a little bit past the mean. 21.7, that's your X value. And you want to be less than that. Okay. Less than is to the left. So I'm looking for this red shaded region. So I have everything I need to know. I'm going out to Minitab. Again, it's graph, probability distribution plot, view probability. It is a normal distribution, mean of 21.524, standard deviation of 2.419. My options. Okay, and I forgot to mention here, notice that this region is to the left. So this would be left tail. And again, it says find the probability. So I'm using a specified X value. Okay, so a specified X value. This time it is a left tail. So I'm going to click on the left tail. My value is 21.7. I click OK. I click OK. And again, we get this graph. Okay, again, it shows us that it's normal, the mean, the standard deviation. It gives us a shaded region. Again, what you're looking for is this number right here. It's kind of hanging out in the space. So my answer is 0.5290. Again, that's a decimal. If we put it as a percentage, it would be 52.9% chance that a randomly selected student has a reading ACT score less than 21.7. Questions? Are you guys okay? All right, next question. I'm trying to do one of each type scenario. It's the same scenario that we just were talking about, okay? You have a normal distribution. It tells you it's normally distributed. It tells you that the mean score was 21.524. It tells you that the standard deviation is 2.419. Okay, we're using the same scenario, but this time it says find the probability that a randomly selected student will score between 18 and 24. Okay, so again, if I think about visually what this would look like, I have my horizontal number line, my bell-shaped curve, my mean in the middle, which is 21.524. My point, I actually have 2 points of interest because it says I'm between. So you have 18. Well, 18 is going to be somewhere below the mean on the left side, and 24 is going to be above the mean on the right side, and we want to be between. So we're looking for this red shaded region between those two numbers. Now, again, Minitab refers to this, that word between, it uses the word middle because I'm kind of in the middle of the graph, or I'm in the middle of two numbers. Again, it says find the probability. So I'm using the option a specified X value. Got everything I need. I'm going out to Minitab. Graph, probability distribution plot, view the probability. It is a normal distribution with a mean of 21.524, standard deviation of 2.419. Options. Again, now I have a specified X value and I'm between them or in the middle, so I'm choosing middle. The first X value should always be the smallest one, so it was 18. The second one should be the greatest one or the highest one, and it was 24. I click OK. I click OK. And again, in the top half of my window, my graph appears. Okay, again, it gives you the graph. You're looking for this number that's kind of hanging out in the space that represents that red shaded region. It is 0.7744, which means there is a 77.44% chance that a randomly selected student has a reading ACT between 18 and 24. Now, on most of your homework problems, guys, you're not asked to write out that explanation. I'm writing it out intentionally because I want you to understand what that means. When you find that value of 0.7744, what does that mean? How would you interpret it to report it back to somebody should you need to do so? Okay. All right. Example 4 is a different scenario from the ones we've been looking at, but this also, I want to stress that this one is the special case. Okay, and this is the one sometimes that students struggle with. So I want to emphasize that this is the special case. This is kind of that outside. And it says, women's heights are normally distributed with a mean of 63.6 inches and a standard deviation of 2.5 inches. The U.S. Army requires women's heights to be between 58 inches and 80 inches. Find the percentage of women meeting that height requirement. Okay, I'm sorry, this is not the special case. Let me do the next problem. This is another between. Okay, let me move on to the next one. Okay, this is the special case. Okay, and I already have it written on there. This one says, a computer is used for office work at home, research, communication, personal finances, education, and da, 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 da. Suppose that the average number of hours a household personal computer is used for entertainment is 2 hours per day. Assume the times for entertainment are normally distributed and the standard deviation for the times is half an hour. Find the probability that a household computer is used less than 1.8 or more than 2.75 hours per day. Okay, again, a couple of things let's point out. Okay, one, it tells us that my values or the times are normally distributed. It uses a lot more words, but it does tell me that the average or the mean is 2 hours per day. And it tells me that the standard deviation is half an hour or 0.5 of an hour. And then my conditions are that it's less than 1.8 or more than 2.75. Okay, so I have all my information because I know it's normally distributed. I have the mean and I have the standard deviation. Okay, so let's kind of look at this picture here. Okay, so we have our normal distribution. We have our bell-shaped curve. The mean, which is the middle, is 2. My points of interest are that it's less than 1.8. So 1.8 is going to be somewhere below the mean, 1.8, and we want to be less than. And then the other one is 2.75. Which is greater than. This is an OR. Now, again, this one, because it does say find the probability, you're still going to use a specified X value. But the problem is Minitab does not calculate this value directly. Okay, you have to kind of do an extra step. What Minitab is going to calculate for us is going to be this piece in the middle. Okay, this is what Minitab calculates. Minitab calculates the middle. It's sort of like you want to get into the middle of the brownies. You don't want one of the edge pieces. So Minitab is going to calculate what's in the middle, but then we have to take that away from the whole. There's an extra step here. We have to do 1 minus the middle that Minitab calculates. We have to do an extra hand calculation. Because if I take away what's in this middle, whatever's left would be the red zones or the edges. I'm using a value of 1, remember, because the total area under that curve is 1. Okay, so this one's a little bit trickier because you have to do an extra step. But I can still have Minitab help me. Okay, so we go out to Minitab. Graph, probability distribution plot, view probability. It is normal. My mean is 2. My standard deviation is half an hour. Again, I'm going to do a specified X value, but I'm doing the middle. My middle is between 1.8 and 2.75. Those were the 2 points of interest. Again, X1 should be the smaller of the two values. X2 would be the larger of the two values. Now, this picture that you're about to see isn't going to look like the one I drew, because what Minitab figures is, again, that middle. Let me copy this over here and see if I can help you make sense of it. Okay, what Minitab has calculated, this is the middle. This is that piece that I pointed out as yellow. Okay, and its value is 0.5886. But that's not my answer, because what I want is this area out here. This is what I want, is this region over here and this region over here. So I got to do 1 minus that middle of 0.5886. I'll have to get my handheld calculator. So I have 1 minus 0.5886, which gives me 0.4114. This is the actual answer. That 0.4144 represents these two red regions. The red is 0.4114. Okay, it's a little different. And so we would say that there's about a 41% chance that a household personal computer is used less than 1.8 or more than 2.75 hours per day for entertainment. Questions? All right, we're going to shift gears then. We've got to look at the other side, or the other type of problems that you might encounter. Okay, the other type of problems, which again, I often refer to as type 2. Again, that's not a standard terminology, but again, I try to help you make a distinction between the two. Okay, type 2 is, they're usually called an inverse normal distribution. We think about them being inverse because we're working backwards. We know the probability or the percentage, and we're trying to find that specified X value or the cutoff score. I mean, think about it. How do they know when you see, a score report for SAT or ACT? How do they know that you're in the 85th percentile? They probably have used a similar method to this to determine what score corresponds to the 80th percentile. So this is called an inverse normal distribution. And again, you start out knowing the percentage and you're working your way backwards to the specified X value. Again, I've given you, this is the other slide you may want to print off, because this slide, which is slide 19, gives you the instructions for the inverse normal probability distribution. Again, you still have to read the scenario. You still have to know that it's normally distributed. You still have to know the population mean. You still have to know the population standard deviation. And again, the picture will help you decide whether you have a right tail, left tail, the between or the middle, or the outside. Again, it's going to be rare you ever see an outside with the inverse normal distribution. So you want to focus on left tail, right tail, or middle. And again, you have the mini tab instructions there, and they're almost the same, except now we are given a specified probability and are trying to find the X value. So that's where the instructions differ. So again, the two slides that I would strongly suggest you print are number 12 and number 19. Okay, so we're kind of back to our ACT test again. It says, according to the American College Test, results from the 2022 ACT testing found that students had a mean score of 21.524 with a standard deviation of 2.419. Assuming the scores are normally distributed, find the 80th percentile. Okay, again, in the scenario, notice that they tell us that it is normally distributed. They give us the mean. They give us the standard deviation. But then the question says, find the 80th percentile. It doesn't have anything like that it's greater than, less than, whatever, below a certain number, okay? 80th percentile represents, this actually represents, let me get my pen. This corresponds to your probability. It says 80th percentile, so that's 80%, or as a decimal is 0.8. It's also important that you remember that whenever you're thinking about percentiles, remember percentile is the percentage below or to the left, so that you interpret this correctly. So if I want to think about a picture here, here's what this looks like. Okay, so I have my normal distribution. The mean is in the middle, which is 21.524. Now remember, the mean is the measure of center. If it's in the center, that means that line is dividing that distribution so that 50% is below and 50% is above. Okay, you have to remember that. You have to remember that that mean is the measure of center and is dividing it so that you have 50% below, 50% above. That's important because when you go to indicate where 80% is, you got to draw the bar in the right place. So we're looking for the 80th percentile. Well, remember, this is going to run from the left side would be 0, the right side goes up to 100% as you move across that scale. It goes 0 to 100. So 80% is going to be somewhere over here on the left. In that area below that line, I would have 80% of the data. You have to go back and remember how to interpret a percentile. Percentile is the percentage below that value. So what I'm looking for is this X value that I do not know at this point. In Minitab, this is what they call, you are given a specified probability. Now, in the question itself, it could be stated as a percentile, it could be stated as a percentage, or it might be stated as an actual probability. Regardless of how it's stated, you have to enter it as a decimal, okay? It's a specified probability, but you have to enter as a decimal. Now, if you don't remember how to convert from a percentage to a decimal, go back to the algebra review, but it's basically you divide by 100. Okay, so I'm going out to Minitab. Graph, probability distribution plot. We still want to view the probability. We have a normal distribution. The mean is 21.524. The standard deviation is 2.419. That's given to me in the problem. I'm going to options. This time I have a specified probability. that is in the left tail, because the percentile is always the percentage below or to the left. So it's to the left, and the amount is the 80%. So that'll be 0.80 written as a decimal. I click OK. I click OK again. And you get, let me copy the graph where you can see it. It's hard to see over here. Okay, notice again, oh, good grief. On my curve, okay, you have your bell-shaped curve. The mean is in the middle. Here's the mean. And this red region is 0.8. It shows that it's the 80%. This time, what I'm looking for, remember, is the X value, and that X value is this number right here. This is the X that I'm looking for. The 80th percentile corresponds to an X value of 23.56. So if a student scored 23.56 on the ACT, we would report that they are in the 80th percentile. The 80th percentile is 23.56. Now, again, it's a little bit different, and it required a little bit more explanation, because you have to remember how to interpret a percentile, which is something that students tend to forget, or they do it incorrectly. So please be careful. Next question says, the lengths of pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. If we stipulate that a baby is premature if the length of the pregnancy is in the lowest 4%, find the length that separates premature babies from those who are not premature. Premature babies often require special care, and this result could be helpful to hospital administrators in planning that care. Okay, again, notice in the scenario, it tells us that it's normally distributed. It tells us the mean is 268 days, and it tells us the standard deviation. And then it tells us, and the words are important here, guys, that babies born in the lowest 4% are considered premature. Okay, so let's see if we can sketch this out. Horizontal number line, bell-shaped curve. The mean is your measure of center and is in the middle and is given as 268. And it's telling us that there's this kind of this imaginary line that if a baby is born before a certain number of days, it's considered premature. If it's born after that, it's not. And that line occurs at the lowest 4%. Okay, that word lowest is important. Okay, because remember, we start out on the left at 0 and we go all the way up to 100%. So if we're in the lowest, I hope you realize that lowest is going to put you on the left. So the lowest 4% is going to be somewhere here on the left. Lowest 4%, because it's on the low end, which is on the left. And what I'm looking for is the X value that corresponds to. How many days would that be? Now, 4%, just to remind you, 4%, to get to a decimal, you do 4 divided by 100, which is 0.04. Let's go to Minitab. Graph, probability distribution plot, view probability. My mean was 268 for the normal distribution. The standard deviation, I forgot, was 15. Whoops, not 25, 15. Options, again, I have a specified probability. It's still in the left because it was the lowest, but it was 4%, 0.04. I click OK. OK. And it gives me the graph. So let's copy it where you can see it. Here's our graph. Again, you gotta get the same sketch that I got. Again, you have your X labeled in the middle. It shows that the 0.04 is the red shaded region. Again, what you're looking for is this number on the horizontal number line. So 241.7. So if a baby is born before 241.7 days, it's considered premature. Okay, so babies, let me get a different color so you can see it. Babies born before 241.7 days of a pregnancy are considered premature. Questions? Guys, I don't have the benefit of seeing your faces if you're confused. So if you have a question, you have to either unmute and speak, or you can type it in the chat. I sometimes can tell if there's something in the chat, sometimes I can't. So speaking is better, but I'll take either one. Okay, let's look at this next one. It says, men's heights are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. The standard casket has an inside length of 78 inches. A manufacturer of caskets wants to reduce production costs by making smaller caskets. What inside length would fit all men except the tallest 1%? Okay, so again, if you walk back through this problem, it tells you it is normally distributed. It tells you that the mean is 69 inches for men's height. It tells you that the standard deviation is 2.8 inches. Now it tells you that the casket is normally 78 inches long. Okay. It's extra information. I don't really need to know that. But we're trying to find what length we can make a casket that would fit all men except the tallest 1%. So again, let's think this through. We have our horizontal number line. We have our bell-shaped curve. Our mean is in the middle, which is 69 inches. This time we're trying to exclude the tallest 1%. So again, think that through. Use logic, common sense. Remember, from the left we go from 0% to 100%, or from short to tall, if you want to think about it that way. So when you think about the tallest are going to be on the right. Okay, tallest is going to be to the right. So our cutoff value is going to be somewhere on the top half. We're going to exclude the tallest 1%. So these men up here would be out of luck. They would have to special order a casket, but I want to figure out what length that could be. So I'm looking for the X. Okay, again, 1%, you have 1%, that's 1 divided by 100 is 0.01. Be careful. So this one, when you go into Minitab, this is actually going to be on the right side, or a right tail, because again, you're excluding those that are tall. Tall men are going to be bigger than the average, or to the right of the average. Out to Minitab we go. Graph. Probability distribution plot. View probability. It's normal. My height, my mean was 69. Standard deviation is 2.8. Options. We have a specified probability, and this time it's on the right side, or the high side, so it's the right tail, and it's 1%, 0.01. I click OK. I click OK. And I get this graph. Okay, again, you've got your bell-shaped curve, your mean is measured in the middle, you have your label of 0.01 in the red region. Again, you're looking for this number on the horizontal number line. It is 75.51. So the manufacturer could shorten his caskets to about 75.5 inches. He could shorten them by 2.5 inches. Okay, so he could make the caskets to be about 75.5 inches as opposed to 78, saving 2.5 inches. And you may think, well, Ms. Rawson, that's not a big deal. But guys, think about it. If you're making hundreds of thousands of caskets and you're reducing each size by 2.5 inches over a period of time, that's going to reduce the amount of supplies that you need. Trying to see if I have one then that's an or. Okay, I don't see an or in here. And generally you don't see those, or you don't really see a middle. It's very rare that you're going to see one that's in the middle. I have several more examples. I'm happy to work through those if you all need to see them. Do you need to see more examples? Do you feel comfortable? Questions? Okay. Remember that I have delayed the opening of exam 1. Okay. I've delayed the opening of exam 2. Because I want you to have an opportunity to work through these problems, and then if you need to ask questions on Monday. Okay, so kind of here's where we are. We've got about 30 minutes. If you all want to take a couple of minutes, and I'll stay in the room and you can begin working on class participation 7. That way, if you have questions, I can answer them. Let me go out. Let me see if I've got class participation 7 open. I don't, but let me open it because I want to make sure you understand what you need to do. Okay, you're going to use the data set that I provided, the class participation survey data set that you've been using throughout 4, 5, 6, and so forth. Okay, you'll have to use Minitab to calculate your descriptive statistics. You have to calculate the sample mean and the sample standard deviation. Those are the values you will use for your mean and your standard deviation. We're going to assume that the GPAs are normally distributed, and then I ask you a series of questions about the GPAs. Okay, you have to do the descriptive statistics. Kind of helps you to see how it all goes together. You have to do the descriptive statistics and know that it's normally distributed in order to work through the problems. Okay, so class participation 7, I'll stay in the Zoom room. You can begin working on it. If you have questions, you can type it in chat or speak. But remember that your mindset learning activity number 3 is due by Friday. And then by Sunday, you have class participation 6, class participation 7, contingency tables homework, the normal distribution homework. There is a Z-score question. You may want to go back to the January 25th video at about the 1 hour and 45-minute mark. Excuse me if you don't remember how to do that. Okay, any questions? Okay, again, we've got about 25 minutes left, but I will stay in the room and you can begin working on class participation 7. And if you have questions, I'll be happy to try to help you with that. Otherwise, I am done for the day.